All right, so we are still on 11.1, first derivative in their graphs. I'm going to walk through the whole thing. So the last several videos I started and stopped because sometimes it's easier to watch little chunks more than just one whole thing. So I will try and do this as quickly as possible. I like to keep my videos under 10 minutes, but we'll see how this one works. Okay, so here's my function. Negative x to the fourth plus 50x squared. All right, so as we walk through this process, so this is actually on Canvas. If you want to print it up, just go to 11.1. It might say 12.1. It depends on which version. I think I changed them all to the right, to the 14th edition. So here we go. First things first, we need to find the domain. So the domain, remember, for any polynomial is negative infinity to infinity. Again, at this point, the domain isn't going to change, make any huge difference, but I think in my math lab it does ask for your domain. It also asks where is it increasing, decreasing, and finding local extrema. So next step, we're going to find the derivative. I'm trying to keep as much room on my whiteboard as possible. So here we go. Using the power rule, my exponent goes to the front and multiplies, and then I subtract 1. Exponent goes to the front and multiplies, and then I subtract 1. Okay? Not so bad. You guys have been doing this forever. So here we go. Now we're going to set the derivative to 0 and then solve for x, finding the critical points. Okay? First derivative, critical points goes together. So here we go. We're going to set this to 0, and then we're going to solve. All right, now factoring, there's a 4x in common. I'm going to factor out a negative. It just makes it easier. I end up with x squared minus 25 equals 0. Now this is the difference of two squares, so remember your factoring skills. If you don't remember factoring skills, go back to the videos that I have posted earlier in the semester. So difference of two squares. I'm going to take the square root of each one. One's minus, one's plus. I still have a negative 4x out front. Now, if you remember, on the last one, this number out front didn't have an x. Now it does. So now we have to deal with this, okay? So we're going to set each of these terms to 0. Whenever there's an x involved, I have to solve for x. So I'm going to set each of the terms to 0 and then solve. So this one, x is going to equal 0. This one, x is going to equal negative 5. This one, x equals positive 5. So what I just found were my critical points. Okay? So critical points are 0, 5, negative 5. All right? I got to erase so that I can work with this. And I'm going to rewrite my derivative in factored form because I like using this to find out what my interval is doing. All right, so we found our critical points. Next step is we're going to draw a sign chart. So we have our sign chart with our critical points. Now we have 3 critical points, so we have to have 3 points on our first derivative sign chart. So make sure you put them in order. So negative 5, 0, positive 5. Those are the 3 3 critical points. Now I'm just testing intervals. Okay, I'm seeing where is it positive, where is it negative. So here we go. I have an interval of negative infinity up to, but not including negative 5. So I'm going to use my first derivative, which is right here. Negative 4 times negative 10 is a positive. Negative 10 plus 5 is a negative. Negative 10 minus 15 is also a negative. So in this first interval, it is an increasing slope. Okay, so again, all I care about is it positive or negative? I don't care about the value. All right, next interval. Between negative 5 and 0, I'm going to choose negative 1. And again, you can choose any value you want. Doesn't matter. Just pick a value within that interval. Okay, so negative 1. Negative 4 times negative 1 is a positive. Negative 1 plus 5 is a positive. Negative 1 minus 5 is a negative. So in this interval, it is a negative. Now, another easy way to find out if it's positive or negative, and this is why I like this technique, is you just count the number of negatives. Here I have an even number, so it's positive. Here I have an odd number, so the whole thing's negative. So it's negative here, it's going downhill. Now I'm going to test this interval between 0 and 5, so I'm going to pick positive 1. So again, negative 4 times 1 is a negative. 1 plus 5 is a positive. 1 minus 5 is a negative. I have two negatives, that's an even number, so that makes that interval positive. So it's going to go uphill. Now, if you notice, with 3 critical points, I have 4 intervals that I have to test. So you will always test one more interval than the number of critical points that you have, because it just breaks up your number line. So here we go. First derivative, anything over 5, so I'm going to use the number 10. Negative 4 times 10 is a negative. 10 plus 5 is a positive. 10 minus 5 is also a positive. I have one negative, that's an odd number, which makes this interval, extend this a little bit, makes this interval negative. Okay, so remember, your test chart is a great indicator of what your graph is going to look like. It goes up, down, up, and then down. You see it? So now we have to identify our relative extrema, our max and our min. So wherever it goes up, then down, that's a maximum. Wherever it goes down, then up, that's a minimum. And wherever it goes up and then down again, that's also a maximum. So with relative extrema, you can have more than one max or min. Doesn't matter. It's relative. It's not one specific max or min. It's however many maximums we have and however many minimums we have. Okay, so now I need to erase. I'm going to keep my test chart because it will help me graph. So the last step is, or I'm sorry, the second to the last step is to evaluate your max and min. And all that means is you're plugging in your x value back into the original function. Remember, it's always back into the original function. So at negative 5, my original function is here. So I have a negative 5 to the 4th power plus 50 times negative 5 to the 2nd power. So at negative 5, where on my graph is that minimum? How high up does it go? So when you work this out, where is it? Oops, looking at the wrong one. I don't have my calculator with me, so I'm just going to cheat a little bit. So this is negative 5 to the 4th power is 625, but this negative makes it a negative 625. And then 50 times negative 5 is a negative, 50 times negative 5 squared. So negative 5 squared is a positive 25. So 25 times 50 is 1250. So negative 25 plus 1250 is a positive 625. So one of the maximums is at negative 5, 625. Okay, now we're going to evaluate our minimum. Again, back to the original function. So when x is 0, so this dumps out to 0. You don't even have to do this, but I'm showing it to you so you don't accuse me of skipping steps. So 0 to the 4th is 0, plus 50 times 0 is 0. So at 0 is our minimum. So our minimum is at the point 0, 0. And now we're going to do our other maximum. And again, back to the original function. Okay, so we have 5 to the 4th power is 625, but I want the opposite of it, so it's negative 625. 50 times 25 is 1250. So again, we have 625. So at the The other maximum is at 5, 625. Okay, so let me erase one more time. And again, if you miss this, you can always stop and start it. That's the beauty of videos. Okay, so here's our 3 points. So the last step is we're going to graph. Okay, so we have our graph. We're going to plot our points. So at -5, 625, so I'm just going to pretend here. There's -5. Here's our maximum at -5, 625. Then we have a minimum at 0, 0. And then we have another maximum at 5, 625. Okay? All right, so here we go. It goes up, hits our max, goes down, hits our minimum, then it turns around and it goes up, hits our max, and then goes down. And there's your graph. So remember, your test chart really is a picture of what your graph is going to look like. Up, down, up, and down. And you're done. That's it. Okay, your turn.